Welcome to this video on subsoil investigation, which is fundamental to architecture and engineering construction. Subsoil investigation, or underground soil testing, is a method used to verify the physical and engineering properties of soil. This helps with site characterization, risk mitigation based on soil type, and creating a safe design for stability. The objectives of the investigation include determining the soil's bearing capacity, identifying the depth and type of different soil layers, and determining the groundwater table. The investigation process involves several phases: planning, fieldwork, lab testing, and finally, reporting with recommendations and bore logs. Preliminary investigation, or reconnaissance, involves inspecting the area before starting the main fieldwork. This includes observing the condition of adjacent buildings, verifying coordinates and drainage, and identifying access routes for heavy machinery. Methods of soil boring include auger boring for soft, shallow soil, wash boring, which is very common in Bangladesh and uses high-pressure water to loosen soil, and rotary boring, which uses a rotating bit for hard rock or stony soil. The Standard Penetration Test, or SPT, is the most popular test to measure soil consistency. It involves dropping a 140-pound hammer from a 30-inch height. The N value is the number of blows needed for the final 12 inches of penetration. Soil sampling techniques include collecting disturbed samples where the natural structure is lost for grain size and plasticity tests. Undisturbed samples retain their natural structure and water content for strength testing using a Shelby tube. Groundwater table observation is crucial for foundation design. The water level is measured 24 hours after boring is complete. If the water table is high, foundation stability may decrease, requiring dewatering planning. Laboratory testing includes analyzing physical properties such as sieve analysis for particle size, Atterberg limits for clay plasticity and water content, specific gravity, and natural moisture content. Engineering properties tests include the consolidation test to determine soil settlement, the direct shear test for granular soil strength, and the unconfined compression test for clay soil strength. A bore log is a graphical chart of the soil layers. It contains the soil type according to depth, the graph of the N value for each layer, and the main results from the laboratory tests. Bearing capacity analysis involves mathematical analysis of how much weight the soil can support. The final decision on whether to use a shallow foundation or pile foundation is based on this result, often using Terzaghi's bearing capacity equation. The geotechnical report is the final documentation. It compiles field and lab data, analyzes soil strength and depth, and provides foundation recommendations regarding the type and necessary depth of the foundation.